Hey everyone! Welcome back to our channel where we explore the fascinating world of artificial intelligence and machine learning. I'm your name, and today we're diving into the world of activation functions. Specifically, we'll be discussing three popular activation functions used in neural networks: ReLU, Sigmoid, and TAN. So, grab your notebooks and let's get started. But first, let me ask you a question. Have you ever wondered how neural networks make decisions? What helps them understand the complexity of data and learn from it? Well, the answer lies in these activation functions. They play a crucial role in determining the output of a neural network. So, let's break down each of them. Let's start with sigmoid. The sigmoid function is one of the oldest activation functions, and its formula is quite simple. It's defined as f equals 1, where e is Euler's number, approximately equal to 2.71828. What does this function do? Well, the output of the sigmoid function ranges between 0 and 1. This makes it especially useful for binary classification problems, where we want to predict probabilities. For example, if you're building a model to determine whether an email is spam or not, the sigmoid function can help output a probability score between 0 and 1. However, the sigmoid function does have its drawbacks. One major issue is what we call the vanishing gradient problem. As the input values become very large or very small, the gradients approach 0. This means that during backpropagation, the updates to the weights become minimal, causing the learning process to slow down significantly. Now, let's move on to the TAN function. TAN, which stands for hyperbolic tangent, is another activation function that we often use. Its formula looks like this: f equals. Unlike the sigmoid function, TAN outputs values between -1 and 1. This property makes TAN a better choice than sigmoid for many applications, as it centers the data around 0. This can help improve convergence during training. For example, if we're trying to predict stock prices, we might use TAN to transform our data before feeding it into a neural network. The TAN function helps the model learn effectively by ensuring the data maintains a balanced distribution. However, TAN also suffers from the vanishing gradient problem, especially for very large or small inputs. This is an important consideration when choosing which activation function to use. Next, let's talk about the ReLU function. ReLU stands for Rectified Linear Unit, and it's gained a lot of popularity in recent years. Its formula is straightforward: f equals max. This means that if the input is positive, it remains unchanged; if it's negative, it becomes 0. The beauty of ReLU lies in its simplicity and efficiency. It does not suffer from the vanishing gradient problem for positive values, allowing models to learn faster and perform better in many cases. For instance, in image recognition tasks, using ReLU can significantly speed up the training process. A common scenario is when you're building a convolutional neural network for facial recognition. ReLU helps the model learn complex patterns without getting stuck due to small gradients. However, ReLU is not without its challenges. One issue is the dying ReLU problem. This occurs when neurons become inactive and always output 0, which can halt the learning process for those neurons. To mitigate this, variants like leaky ReLU and parametric ReLU have been introduced, allowing a small, non-zero gradient for negative inputs. So, to summarize what we've learned today, the sigmoid function outputs between 0 and 1, making it useful for binary classification but can suffer from vanishing gradients. The TAN function outputs between -1 and 1, centering the data for better learning, but also has vanishing gradient issues. The ReLU function is popular for its efficiency and speed in training but can lead to inactive neurons. Understanding these activation functions is key to optimizing your neural networks and achieving better performance in machine learning tasks. If you found this video helpful, please give it a thumbs up, share it with your friends, and consider subscribing for more content on AI and machine learning. Got questions or topics you want us to cover next? Drop them in the comments below. Thanks for watching, and see you in the next video.